Hello everyone. In this video, we will discuss about aluminosilicates, what are aluminosilicates, what are the different kinds of aluminosilicates, and what are the various applications of different aluminosilicates in different areas. Now, before going to discuss further process, now let us discuss what are the learning outcomes of the present video. And we can see that after studying this lecture, you shall be able to understand what are aluminosilicates, and you can also know the important classes of aluminosilicates, and we can also differentiate aluminosilicates and different kinds of aluminosilicates, like we have clay, we have mica, geolites, and fuller earth. That we can see that geolites are the basically materials which is mainly utilized for the water softening method, etc. Now discuss about aluminosilicates. As we are discussing aluminosilicates, the first question arises how we can define the aluminosilicates. So basically, aluminosilicates are the minerals which are a group of minerals which contains the compounds like we have alumina, that is Al2O3, and silica, that is SiO2. Hence they are referred to as aluminosilicates because they are prepared by mixing the alumina and silica with each other. Then we are getting the aluminosilicate, and this is the ball and stick model of the aluminosilicates, in which we can say that one alumina and silica molecule is bonding with each other. That's why they are forming the aluminosilicate mineral. As we know that alumina and silica are of two most common compounds in the earth crust, and if basically they are found inside the earth, so as a result they form some of the most common minerals on earth. And many gemstones, like we have different types of stones we are using for our jewelry purposes, which also includes emeralds. These are also included in the category of aluminosilicates. Further, we tend to think of gemstones. These are very hard, but other types of aluminosilicates minerals are very clay-like in their texture and structure. Yani ki they are having soft and they can be cut this knife. So they are having clay-type structures, as we know that like children are using the clay for making different shapes. So they are having some clay-like properties, textures, and because of their clay-like features, they can also be ground up and used for making china, clay, yeah, we can say china and pottery products, or that can be also utilized as a industrial lubricants. Now come to the further discussion. As we can see, these are the natural pictures of the aluminosilicates. Examples are like we have andalusite, kyanite, and silimonite. So in this case, this is the picture which is shown for the naturally occurring aluminosilicate, as the andalusite, and this is the picture which is the blue colored and white picture, it is of a kyanite. So when some of the Si4 ions in the silicates are replaced by the Al3 plus ions, for each Si4 ions replaced by the Al3 plus, in that case charge must be balanced by having other positive ions like we have Na ion, K ion, and Ca2 plus ions. So these are the further examples are for aluminosilicates, like we have andalusite, kyanite, and silimonite. These are the some of the naturally occurring aluminosilicates minerals that have the composition like we have Al2O SiO4, where both alumina and silica they are joined with each other. One of the common example, also known as topaz, is closely related in the chemical composition, that is having the chemical formula Al2SiO4 OHF whole twice. This is the chemical formula for the topaz. Now another example is we have another important example of aluminosilicate is the beryl, which is having the chemical formula Be3. Al2O3, SiO3 whole 6, which contains the rings of SiO3 whole 6 type, and it is also usually found in cavities of the granites, that is found in case of granite cavity. And this mineral is also known as, other names of minerals are aquamarine, which is also referred to as a precious stone. And this is the main source of beryllium metal also. So these are some of the important aluminosilicates, like we have micas, we have clay, we have fuller's earth, we have talc and geolite. So these are the some of the important aluminosilicates which is mainly obtained either in the natural earth crust, yeah, we have manufacturing by man-made. And these are the pictures for, this is for the mica. We can see it is a naturally obtained which is found on the earth crust. This is a picture of mica. It is a structure shown for the clay, and this picture is shown for the geolite, which is the white solid stone type structure, and this structure is shown for the talc. So on the basis of different color, we have that, like we have white talc also. So this is the structure of the talc, which is naturally obtained from the earth crust, and this is obtained from the earth crust in the form of some powdery and this is the solitary structure, that is the fuller. So these are some of the pictures and names of the some important aluminosilicates. Now let us take first category of aluminosilicates, that is mica. So as we know that general formula for mica is XY2 minus 3Z4O10 OHF whole twice, where X is equal to, it can be K, that is potassium, it can be Na, that is sodium, or it can be Ca, that is calcium. While in place of Y, we can put the metals like we have aluminium, that is Al, magnesium, that is we have magnesium Mg, and that is iron, that is Fe. Or in place of Z, we can put the value Si, that is silica, or Al, that is aluminium. After putting, we can get the different examples of the mica. As shown in the structures, these are the two structures for the examples, like we have trioctahedral Phologophyte, that is having the formula KMg3AlSi3O10OH whole twice, and we have dioctahedral, that is mucostivide KAl2AlSi3O10OH twice. In this both structures, this circle, that is blank circle, these white dots, they represents the oxygen atom, while these dark color circles, these one, they represent the OH minus ions, while these small circles, they represent the Mg ions, while these structures represent the Al ions, while these black colored dots, these represent the Si4 plus ions. So these are the structures for the examples of the mica. Examples actually we have mucosovite mica, which is having the formula KAl2AlSi3O10FOH twice. And we also know that micas are amphiboles, which are made up of sheets of tetrahedron in which SiO4 4 negative ion is replaced by the AlO4 5 minus tetrahedron. So we can say that they are chemically inert, that means they do not react with anything, and they are thermally stable, that can bear the temperature, very high temperature, they are thermally stable, and they have the high dielectric constant, due to which mica can be utilized in furnace windows or various electrical appliances. Further, powdered mica is also utilized as the filters for rubber plastics and insulation boards also. Now come to the second category of aluminosilicate, that is clay. As we know that clay minerals are basically hydrous aluminium phyllosilicates, and sometimes with variable amounts of iron, magnesium, alkali metals, alkaline earths, and other cations, which are found on or near the planetary surfaces. So these are the structures for some of the examples of clay, which are very common example of clay. That is, we are having kaolinite and we have pyrophyllite, whose formulas are for kaolinite is the Al2Si2O5 OH4, while for pyrophyllite it is having formula Al2Si4 O10 OH twice, where in its structure we can see that we are representing some atoms on different colors. Here that blue color atoms they represent for the oxygen, while these red color atoms they represent for the in both structures, that is for Si4 plus, while these green color atoms in the both the structure they represent the OH minus ions, while these purple color atoms in both structures they are representing the Mg2 plus ions. So they can also be produced by weathering and decomposition of ignition rocks. Like example, we have already discussed some common example like we have China clay, whose formula is Al2OH4 Si2O5. Another example is kaolinite, which has the sheet type structure, that is sheet type structure which are held by the OH bridges in between them, and they can also be utilized in making the China wares, fire bricks, and various other applications. If we are heating these clays at 900 degrees centigrade, so they can form the mullite, that is having the formula Al6SiO2O3. Yeah, we can also refer as 3Al2O3 2SiO2, which is having a glass type appearance in that case. Now let us take another category of aluminosilicate, that is fuller's earth. Fuller's earth is any clay-like material that has the capability to decolorize oil or other liquids without chemical treatment. And this is the structure for the Fuller's earth, in which red color atoms represents the oxygen atom while blue color atom represents the silicon. Fuller earth typically consists of palygoricite, that is also known as attapulgite or bentonite, and they also consist, which is primarily of hydrous aluminum silicates, that is called as clay minerals of different composition, which is having common components in that case are montmorillonite, kaolinite, attapulgite. These are the some common components in case of fuller earth. If we can discuss that it is also the montmorillonite, in which principal exchangeable ion is the calcium ion. Yani in this case, calcium ion is mainly exchange. They can exchange with the other atoms, and we have it is also having the absorption power, which is very strong absorption power, and they are also having the cation exchange property. Yani ki they can replace the cation with the some other cation, so they are also having the cation exchange property. And various other modern uses of fullers include that they can absorb the oil, grease, animal waste, that is called as cat litter, or they can also be utilized as a carrier for pesticides and fertilizers also. And some other uses include that they can be utilized for filtering purpose, clarifying and decolorizing active, inactive ingredients in the some cosmetic and beauty products, as well as in case of paints as a filler, plasters, adhesive, and pharmaceuticals also. Now let us discuss another example of aluminosilicate, that is one of the important examples of aluminosilicate, that is geolines. So first question arises that how we can define geolite. So basically geolite is a class of hydrated aluminosilicates which is mainly found in case of certain volcanic rocks. And once upon a time, Julius that thought that these minerals were very interesting because they consist of large cage-like structures with open channel ways. As we can see, this is the structure of zeolite, which is appears in the form of molecular sheets. Like they can utilize for various filtration purpose also, and they can also utilize for the water softening purpose also, which is one of the important application of zeolite for water softening purpose. So they can also utilize for treatment of water, that can be utilized for industrial purpose. So this is the structure of zeolite, in which case we can say that small atoms that represents the Si4 plus ion, while these big atoms they represents the O2 minus ions, while these black color atoms they represents the aluminum ions in case of zeolite structures. Basically, zeolites are hydrated aluminosilicates that have the capability that they can exchange their sodium ions because their formula is the Na2Al2O3 XSiO2. So in this case, these sodium ions, that is the example of zeolite, that is electrolyte. In this case, these sodium ions, that is cation, they can be replaced if we are using for water treatment purpose. So they can exchange their sodium ions with the cations of the hardness causing salt. यानी कि basically we can utilize zeolite for the water softening purpose. ठीक है. Then, once upon a time, Julius thought that these minerals were very interesting. And today, these minerals are highly valued for their application because they can also utilize for the water treatment purpose. They can also utilize for the irrigation purpose. They can also utilize for agriculture in the form of nanogelites because they can absorb the water which can be utilized for further use. And they have porous structure. As we can see in this case, they have porous structures. They can accommodate a wide variety of cations like calcium ions, magnesium ions, and potassium ions, and some other positive ions that can be absorbed by these zeolites. So these positive ions can either loosely held on these or they can be readily exchanged for the others in contact with the solution. They can be utilized. So for if we are using these zeolites for the water softening purpose, so they can one other another important application that they can be regenerated back. Suppose we are using zeolites one time in a zeolite process that is also known as permuted process, so they can be regenerated back. What is the advantage of this one? That if we are using zeolite one time, so it can utilize several many times for water softening purpose till its life, because when it is getting exhausted after purification of water for the removal of hardness causing salt, we can again and again utilize these zeolites by regeneration by utilizing the brine solution. What is brine solution? Brine solution is the 10% initial solution. So by utilizing brine solution in case of water treatment process, we can also regenerate back the zeolites that can also utilize for the water treatment purpose it again. The examples are natural in which we have Na2O, Al2O3, Si3O10.2H2O. A general formula we can say zeolite for is the that is Na2O dot Al2O3 dot XSiO2 dot YS2 where X is equal to 2 to 10 while Y is equal to 2 to 6. On putting these values, we can get the different examples of the zeolites that can be utilized for various applications. If we further discuss about zeolites, so we can say that zeolites are the aluminosilicates members of the family of micropolar solids that are also known as molecular sieve. As we have seen in the structure of previous slide that they are having sieve type structure in which they can absorb the various types of ions like we have calcium ions, magnesium ions, potassium ions, sodium ions that can be absorbed when we are using zeolites for them. So they can hold these ions from them. And the term molecular sieve basically it refers to a particular property of these metals that they have the ability to selectively sort molecules based on the primarily on size exclusion process. यानी कि in this case if zeolites have a particular size, so they can only allow to pass that atoms into them which are having less size than that of their molecular series and their size. If the atoms, ions, they are having size more than that of their defined size, so that will be stopped by the zeolite, while the atom which is having the lower size than that of the zeolite size, so they will allow to pass into them. So we can sort different molecules based on the size, so that can be utilized for various purposes. And at present, we know that 150 over 150 synthetic geolites and geotypes and 40 other natural geolites are known in the nature, and synthesis of geolites is very active field of the study nowadays because they have very vast application in different areas, like we have for water treatment, we have for agriculture purpose, and we are also utilizing for some solar energy system also. Now come to the various applications of zeolites. Some of them we are discussing in the slides. As we know that zeolites can be utilized as a selective and strong absorbers which can remove the toxic materials. They can also utilize as a selective concentrate a particular chemical that is known as molecular sieve. Geolites can also be utilized as selective ion exchanger. For example, they can also utilize in the water softener, as we have discussed in the previous slide, that they have the capability that they can replace their sodium ion with the positive ions of the hardness scoring salt. So they are also utilized as a material for water treatment process. And these can also be utilized as a super solid acid catalyst when the cations are protons, that is H plus ion. So this is the flow diagram which shows that zeolites can be utilized in different purposes, like they can utilize for the hydrogen production, they can also utilize radionuclide removal, they can also utilize exhaust post treatment, they can also utilize for the CO2 capture, they can also utilize for the biomass conversion, they can also utilize for the thermal energy storage, and zeolites can also utilize for CO2 conversion, and at last they can also utilize for the water separation techniques. Now at last we will discuss what is the summary of the present video. In this video we have discussed what are aluminosilicates, what are the various types of aluminosilicates, like we have mica, clay, geolites, fuller earth that are obtained from the earth's crust. What are the various applications of aluminosilicate that we have discussed in the present video, and how we can differentiate between the aluminosilicates, clay, mica, geolites, and fuller earth, etc. Now these are the some of the practice questions that can be solved by using present video. Then we can say that what are the aluminosilicates. On the basis of video we can write the important class of aluminosilicates, write the uses of aluminosilicates. We can differentiate between aluminosilicates, clay, mica, zeolites, and fullerenes on the basis of this. So these are some of the practical questions that can be solved on watching this video. These are some of the references that can also utilize for making this present video. At last, thank you for your paying attention.